Everyone, and welcome to the next section in the Probability and Statistics series of tutorials. In this one, we're going to be looking at central tendency. And so just a quick definition here, central tendency, the aim of this, the goal is to try to analyze or to summarize large data sets. So something that's very common in, I think, the world of literacy and ELA is that when we have a book, I like to think about if I just read a great book and I'm trying to tell someone about that book, I can't tell them every single detail. I can't read them the book. I just need to be able to summarize into a small piece of information to give and translate what's, in my head or what I think or how I feel about the book. And so that's what a summary is for. And central tendency is one of the ways that we do that with numbers. It's one of the ways that we do that with data sets. We try to analyze or summarize large data sets using smaller amounts of information. And using these measurements, it's really just trying to use one number in order to summarize large data sets. And so the three measurements that we have for that, and hopefully you're a little familiar with these, are going to be the mean, the median, and the mode. And so the first thing that we're going to do is actually just look at, without any context, just look at a set of numbers and how to calculate these. But then we're going to dive into some context, and that's where it gets really important because the realm of central tendency goes much deeper than just being able to calculate these measures. Remember, we said that in statistics and probability and statistics, it's more about being able to inference and being able to understand and analyze that information. And depending on the context and depending on the data set, there are sort of different values or different uses for the three different measures of central tendency. And sometimes we may want to use the mean, sometimes we may want to use the median, and there may be some influences that have dramatic impact on these measurements as well. But first, let's just talk a little bit about calculation. It's hard to understand what those things are if we don't know how to calculate those measurements first. So let's dive right into that. So the mean, this is probably one of the more common measurements. Sometimes the mean is also called the average, but technically speaking, average refers to just central tendency as a whole. So you do have to be a little careful with that verbiage. Sometimes when someone says average, they could mean mean, median, or mode. Sometimes when someone says average, they specifically mean just the mean. So be a little careful. But we're going to start by finding the average. And so the first step of finding the average is going to be finding the sum of all data points. And so the first thing I'm going to do, I'm going to add all of these numbers up, 2 plus 3 plus 6 plus 9, and so on. And I will eventually get 87. That's the sum of all of the data points. Now, step 2 here is going to be divide the sum by the amount of data points. And in this data set, there are 18 data points. So we are going to do 87 divided by 18, and that's going to give us the mean. So it is 4.83. So a little less than 5 is the mean, or 4.83 to be more specific, is the mean of this data set. All right, so now we're going to look at the median. In the median, what you need to remember, the median is just the number that's in the middle. But there's a little caveat to finding this, something you do need to be very careful of. It is the number in the middle, but the data set must be in order. So that's what I'm going to take just a second to do, is to rewrite this data set in order. And I encourage you to do that. If the data set is small enough that you can kind of feasibly rewrite and work it that way, rewrite the data set out so that you have it in order. It's going to be really hard to find the number that's in the middle numerically if that list is not in order. And I like to, if I have something I can write on and actually touch that data set, I like to cross those numbers off as I write them down so that I know I don't forget anything in the end. So 2 is the smallest number. So there's 1, 2, 3, 4 2s. And then we have 3 is my next number. So there's 1, 2, there's 3 3s. And then we have 1, 2 4s. And we have 1, 2 5s. 1, 2 6s. 2 7s. 1 8. And 2 9s. And then just to double, triple check, I know I had 18 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then if I look up here, I did cross everything out. So I have all my numbers. And now I'm just going to find the number that's physically in the middle of this list. Now, when we're finding the number in the middle, we're going to run into 2 different scenarios. If we have an odd amount of numbers, it's going to be pretty easy. It's just going to be that number that's physically in the middle. I'll give you a small example. Let's say our data set was 2, 4, 4, 5, 6. In this case, I have an odd amount of numbers. It's easy to tell what's physically in the middle, the number that has 2 on each side of them. But if we have an even amount, there is going to be one more step, like in the data set that we have here, because we have 18 numbers. So I'll give you another small example so you can see. Let's say we had 2, 4, 5, 5. All right. In this case, there's not a number perfectly in the middle. If we take, 2 off of each side, really, we could say we have 2 numbers in the middle, 4 and 5. And so what we really need here is to know what is halfway between these numbers. And if they're close, like 4 and 5, or 2 and 3, or 12 and 13, we should be able to see pretty easily halfway between 4 and 5 is just 4.5, right? But if we need to, a little calculation we can do in order to do that, you can add them and then divide by 2. And I'll prove that with 4 and 5. 4 plus 5 is 9. 9 divided by 2 is that 4.5. So that's the 2 different scenarios that you could run into with median, if you have an odd amount of numbers or if you have an even amount of numbers. So let's jump back up here and find the median for our original data set. So again, there's a couple ways we could do this. We could just mark them off and work our way in. Or if we know how many numbers we have, like I know there's 18 numbers, I know there's going to be 9 on each side of that. So I'm just going to just go ahead and count in my 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's actually the number that's going to be between 4 and 5, which we actually just did that in our other example set. So here we're going to have 4.5 as the median. All right, and then the last one that we're going to find is the mode. This is probably the easiest of the 3, especially if it's in order. We're just looking for the number that occurs the most, not the most number, not like the highest number, but the number that appears or occurs the most. And in this case, we have 4 2s. There's not more than not 4 or more of anything else. So in this case, our mode is 2. All right, so now we have our three measures of central tendency. And what I want to start to do is talk about some differences and eventually get to this idea that's going to come up and that you need to understand of which one is the best measure. And that's going to be a very case specific type of question. Sometimes the mean is going to be best. Sometimes the median is going to be best. Sometimes the mode is going to be best. Sometimes more than one of them are going to be okay. And so again, it's very, very case by case, data set by data set specific. In this case, just looking at the data and looking at our measures, I would feel pretty comfortable saying that our best measures here, the mean looks pretty good and the median looks pretty good as well. And in just a little bit, we'll talk about what's happening, or rather what's not happening in these data sets that make both the mean and median good measures. The mode, I think more often than not, the mode is not going to be your best measure. Generally, only if there's one number that appears just over and over and over and over again, in a set of data like 18. I don't want to give an answer because, again, it is context specific as well, and we don't have any context here. But I would want to see like 9 or 10 or 11 repetitions of the same number before I would want to start thinking about the mode being the best measure. There's not a specific set number that you have to know. It's context and data set specific. But we would really want to see a number repeating a lot. Or if something's happening that's making the mean and the median both bad measures, then we would go to the mode. But again, the biggest thing is context and the audience, and oftentimes the point that you're trying to make. I think especially in today's world, you can probably understand this. Maybe you've heard that you can make data say lots of things. You can make data look really any way you want. And using different measures of central tendency is one of the ways that happens. So if you're trying to make a point and one of the measures of central tendency does that for you, then of course you would use that. So again, it's very context specific. Now we're going to look at a data set with a little more context and also some scenarios that could impact some of those measures of central tendency, and start to look at why we may want to use one measure over another measure, and why that may be more valuable in some scenarios. And one of the things that we're going to look at in order to do that, and we need to understand, is this idea of outliers. So if you've been keeping a list of vocabulary like I recommended, this is one that you should probably add to that. Understanding outliers is kind of crucial for understanding central tendency and best measures of central tendency, because what outliers do is they can skew the data or skew the data's results. So being skewed or having skewed data results, that's another very important idea. So our context in this scenario is going to be company salaries. So we're looking at analyzing company salaries, and we want to find some sort of measure that describes the company as a whole. We want to summarize what that is. And in this data set, there's not an outlier here. So I'll add an outlier later so we can talk about what that is. But I first want to calculate the measures without an outlier, because I want you to see what happens in the presence of an outlier. So we need something to compare that to. So to find the mean, just like we did before, I'm going to find the sum of all the salaries, which is $258,000. And then I'm going to divide that by the amount or the number of data points that we have, which in this case is 7. So we get a mean salary of $36,857.14. All right, so to find the median, I've already put them in order to make that easier for us. So we'll just go through, find that number in the middle. It's $36,000. And then our mode, only one number repeats more than once, And so in this case, we have $36,000 for a mode as well. Now, to define what an outlier is, I'm just going to add an outlier to this data set. So an outlier is a number that doesn't really go with or match the rest of the data set. It's a number that's either a lot larger or a lot smaller than what the trend or what the rest of the numbers kind of tend to be or tend to sit around. So let's say in this context here, maybe now we've added the CEO's salary into the mix. And so let's recalculate our measurements. So I'm going to take that original sum of the 258,000 and add in that 198,000 to get the new total of all the salaries, which is 456,000. And this time we're going to divide by 8 because we do have one more data set, and we get a mean of 57,000. All right, so now let's find our new median. I'm going to mark this in a different way so that we can kind of see that. All right, and in this one I get both of those in the middle, but looks like I lost a 0 there. Halfway between 36,000 and 36,000 is just still 36,000. And then our mode, again, is still 36,000. So when we're looking at our new calculated values, this is what it means for an outlier to skew the data. It has skewed the data right. So what that means, if you think about a number line, larger numbers are to the right, smaller numbers to the left. So skewing right makes it look bigger than it is. Skewing left makes it look smaller, or makes it look smaller than it is. And so this, in this scenario, would not be a very good description, would not be a good measure of central tendency. I wouldn't want to use this if I was trying to be accurate and describe what the average salaries of these companies are. It falls kind of in here in a weird place because there's not a single employee other than one who even makes that much, and that employee makes well over even double that, almost quadruple what this is. So this number doesn't really do a good job of describing what any of their salaries are. So in this case, if I was trying to be accurate and show what a typical employee makes at this company, 57,000 would not be the number I would want to use. In this case, I would certainly be looking at using the median or even using the mode. But here the mode really only because it's the same as the median. That 36,000 in 8 data points repeats 3 times. I don't think that's enough to really justify saying that the mode is the best measure, but it is the same. So it's hard to use the median without also using the mode because they just happen to be the same number. But in this case, if we were going to say that there was a best measure, again, it would depend on the context. So if the context was trying to be accurate and have a number that describes the typical salary, then the median would be the best measure. If my context was something like, I'm the CEO and I'm trying to inflate the number and I want to make it look like I pay my employees more, well, then I would use the mean, because that's exactly what the mean does. The mean is inflating what those average salaries are. So again, here's what outliers do, and here's how those numbers can be different. And again, depending on the context and the data set and the scenario, we may want to use one set more than another set. All right, so let's look at one more here. Let's look at a little bit more context and another data set that we have. So competing company wants to give the impression that sales were down this year. What measure should they use? So we have this company's average sales by month, and a competing company wants to use these numbers, and they think they can give an impression that sales or down. And so how might we do that? So we have by month, so there's 12 numbers. So let's just looking through this right here kind of sticks out. We have an outlier. And in this case, this outlier is much lower than the rest of the numbers. So if I'm thinking about the measures of central tendency here, well, it's not going to have an impact on the mode because there's only one of them. There's not a bunch of 23,000s. If there were, it wouldn't be an outlier. It's not going to have a dramatic impact on the median because the rest of the numbers are all pretty close. So even if it does shift a little bit where what numbers we're sitting between, it's not going to shift it by much. So it's going to have very minimal impact. But we do know that the mean is going to be skewed, in this case, lower than the typical months. And so knowing that, if we're trying to make it look like sales are down, then the mean is exactly what we're going to want to use because that's what the mean is going to do. Again, this is very dependent on context. If I was trying to give what a typical number was, I was trying to make sure my numbers looked as big as they were. Let's say I do work for this company with this numbers, then I'm going to not want to use that. I'm going to want to stay away from the mean and maybe use the median. But if my context is I'm trying to make it look like the sales were down, then I definitely want to use the mean because it's going to skew that measure lower. So again, very important that we understand the context and we understand what that context and what the numbers in the data set are going to do to the measures of central tendency and find the number that best fits not just the data set, but fits the context and the purpose that we're trying to set. Whether that purpose is good or bad, what fits that purpose? All right, and so that's going to wrap up the section on central tendency. There is going to be a little overlap into the next section as well. We're going to talk about variation, and there is a little bit of overlap, and some of the questions in that section are going to overlap as well. But for specifically central tendency, that wraps this up, and we'll see you in the next.